Tech from West Bengal University and Technology. He has total experience of more than 6 years in academic as well as research. He has good number of publication in various international journals. Not only this, he has published many research works in national as well as international conferences. His research work is not limited to this. He has published few book chapters as well. Along with that, he is a professional membership of IEEE. He is not only the author of various research works, but he is also the reviewer of various international journals related to IEEE, Elsevier, and many more. His research field is related to diverse areas like power system deregulation, unit commitment, renewable energy integration, energy storage, etc. Now, I would like to request our Principal Madam, Professor Dr. Mahua Das, to kindly welcome our Honorable Guest, Dr. Pranda Prasad Gupta. Over to you, ma'am. The virtual dice is yours.
Am I audible? Am I
Yes,
audible?
ma'am, you're audible.
Okay, thank you,
Yes, ma'am.
Arindita.
Yes, ma'am, you're
Hello, everyone. A very good morning to you all. Sorry, I am a little bit late due to network connection. Um, the global pandemic of COVID 19 has impacted our lives significantly. As we weather the global health crisis together, many of us are adapting ourselves, coping with strategies, and developing new ways to combat this pandemic. Engineers, researchers, innovators from various sectors are also working on emerging technology to alleviate the effects of these unprecedented challenges. The advancement of technology and digital communication play a vital role in the current situation where most people have to work from home and students are required to continue their studies through online platforms. With this new model of digitization in many sectors, a paradigm shift has also taken place in the academic sector. We, the total RERF team, are striving also in enriching our students in the best possible way. Today, in this context, the Electrical Engineering Department of Regent Education and Research Foundation has arranged this webinar on power system optimization in GAMS, which can provide the audience much important practical insights on the topic. I take the privilege to welcome Dr. Pranda Prasad Gupta in our virtual platform as the resource person. I also welcome all the participants in this webinar. I know that this session will be an engaging and also enlightening one. Surely, it will be an enriching experience for the audience. We hope to host Dr. Gupta at our campus for more of such engaging session after the pandemic is over. I take further the privilege to thank Dr. Gupta for joining us and sharing his precious time with us. Over to Arindita.
Thank you, ma'am. Sir, you may start now. Before that, I would like to make an announcement. All the participants, please kindly keep your microphone in mute mode and keep your camera off. And if you have any questions during the session, please put it in the chat box. We will ask sir about that during the questionnaire session. So please keep your camera off. Sir, you may start now.
Okay. Uh, may I audible, all of you?
Yes, sir, you are audible.
I'm sharing the slide. Uh, Uh, it is audible to all of you?
Yes, sir. Very well.
Okay. Okay.
Yes, sir.
Thank you, the College of means Regent Engineering College and Principal Madam and all of the participated and the HOD of Vidyut Kumar Ghosh sir. So give me the opportunity of this present the webinar on power system optimization using generative modeling system. This I am from RIT Rajaram Institute of Technology. And right now I'm doing as a post of assistant professor Department of Electrical Engineering. So this is the part of IT Bombay section. These are cover out. Okay. So my outline of this presentation is introduction. First of all, optimization, which optimization software we are done. Algebraic ordinary modeling languages, GAMS solvers, economic dispatch. We have to solve this problem of economic dispatch, unit commitment model, examples, whatever the example we are taking, little bit some example we are sharing, and last of all is the publication and references. Okay. Now, why we are do the power system optimization? Basically, what is the meaning of optimization? The action of making the best or most effective use of a situation or resources. That is the main way to talk about the optimization. The main of the most of the researcher of the power system, we are basically they have done that is AI technique, that is genetic algorithm, PSO, whatever they are doing. But I have done the basically this is the part of GAMS algebraic modeling system. GAMS means it is the basically is the most of the engineering tools. If you are having lots of large number of constraints and large number of variables, then the GAMS solver is the easiest problem to solve this problem. So these are the why by using GAMS, because the question is why by using GAMS, because GAMS is basically they are giving the global optimal or local optimal solution. So that's why we are going to GAMS solution. If you're going for MATLAB, they are giving the different types of solution. If you're going to for iteration, if you go for large number of variables you have, if a large number of constraints you have, so you're taking large number of times. The main importance is that because power system is a complex problem. If you've done large number of constraints and you have add large number of variables, then it takes much time. So GAMS solver is the easiest solver. They reduce the time solution. Okay, so that's why we are needing the GAMS solver. That's most of the engineers, the engineering field, either they are mechanical, either they are electrical, either they are electronics. They are follow the GAMS rule, because recently the IEEE transaction paper in power system, or we can say sustainable, most of the people are flowing the GAMS, because these are the particularly type of real world optimization problem we can say. So these are the most important problem of application of GAMS for optimization in competitive software also. So these are the introduction of how to optimize the power system. Basically, if you say that distribution sense of view, if you say that transmission sense of view, so these are the part of GAMS solver we can be used in our engineering field as well as mathematics field as well as science field. So why we are there are two types broadly classified the power system optimization. First of all is operation, and second one is planning. So what is mean by operation? Operation means we are giving the scheduling, or we can say the dispatch of the solution within 24 hours. Okay. If you go for planning, it may be 365 days, or we can 1 year or 1 month. So they are the planning. So planning having different parts and operation having different parts. So when we are going for planning, they are having different types we have concerned, that is generation excellence planning. Okay. So what is generation excellence planning? Basically in GAP, in generation excellence planning, the decision making is try to find out the investment decision regarding the generation methodology. That is the time of investment. If you go for transmission excellence planning, in TEP, the decision maker is trying to find out the investment decision regarding the planning option and time on investment. So if you go for generation as well as transmission, they are the distributor. They are the planner which having the decision maker to keep the assignment of those planning. So they are in 1 year. Distribution network planning is also a DG part. If you go for DG location in your any network, if you have IEEE 30 bus system, or if you have 6 bus system, whatever. So DG network planning is also giving the building of new investment. We can say the investment in smart investment, or we can say the substation to make the technical constraint. That is a distribution network planning. If you go for fact devices, is also the important problem. If you go for, it is also part of planning. This is the problem is success of transmission planning problem. The fact devices can control the power flowing through a line and make the transmission network more flexible and reliable. That is the most important fact. If you go for DG allocation, we already say about DG is the part of distribution network. It is the optimal allocation or size which can be considered. If you go for capacitor allocation, capacitor is the part of planning, improve the placement of phasor measurement using the network. If you go for energy storage system, because they are having different types of energy storage system allocation. If you allocate the energy and deliver value, the highly depends on how they are operated and located in the system. The problem is that is to try to maximize the benefit by finding the optimal solution of ES to the grid. So we have to find the optimal solution. If you connect energies to a different type of energy storage we have, that is electrical vehicles right now. Most of the researcher, they are doing electrical vehicles and battery energy storage system and compressed energy storage, some different types of energy storage in our field. So most of the researchers, they are going for the energy storage application. They are doing in planning system, because planning is the vast area. If you go for researcher, if you're going for research for PhD or MTech, so they are the power energy storage system is the vast area, because these are the part. If you go for planning having the 365 days or 1 year, so planning is a part of, this is the part, because generational planning is the part of all research. If you're doing for research, generational planning is one other part, transmission planning is one other part, fact device is one of the part. So is the broad area of planning which can be used in our power system optimization problem. If you go for risks and uncertainty modeling, is also the most important factor. This decision-making process highly rely on accuracy of input data, because it depends on input data, where the price forecasting we have, where the demand forecasting we have. These are the uncertainty modeling. Because uncertain means the system are uncertain, because the data is not suitable. They are the uncertain. So uncertainty modeling, which can be used in the decision-making tool, if the uncertainty are not treated and handled properly, they can costly consequence might occur. So we have to use the base of the data availability, some of the following techniques. That is IGBT. Most of the, though many of the your participants you have done, I think so, information gap region theory is the part of uncertainty modeling, and scenario based uncertainty modeling is also part of uncertainty modeling. So these are also all the planning processes which can be handled in the power system optimization area. If you go for operation having, we can say the scheduling, that we can say economic dispatch problem, unit commitment problem, security concern, economic dispatch problem. This is the operation area which can be used in our generation scheduling. And optimal power flow having two types, that is DCOPF and ACOPF, is also the operation problem which can be used. And you can say that ACOPF, there is a neutral raster method which can be used in operation planning also. Hydrogen generation scheduling, hydrothermal operation, reserve procurement, operation of energy storage also. Energy storage also we can do in operation also, as well as planning also. And operation of bidding strategy. Bidding strategy is the part of Genco profit, where the generation companies is bids or offers on the depend on electricity marketing. These are part of bidding strategy. We can say in dealer power system which can be used. Is we use for distributor feeder reconfiguration is also the part. Congestion management is also the most important part of operation. Because what you mean by congestion? Congestion basically it is a machine. It can be defined as the condition where there is insufficient transmission capacity to simulate, implement, or preferred in the electricity market. That we know that congestion management. The line we are congested, we have to elevate those lines. Whatever there is a transmission line with a supplier we given in the generation company, we have to relieve the supply, relieve the congestion. So we have to add the number of energy storage. So these are the part of congestion. Congestion is also the most important factor when we are doing for any work of PhD. Congestion management is the part of PhD work. There are a lot of work researchers are doing in congestion management. Recently they are doing congestion management, and demand side management is also the newly part of research work. Demand side, they are demand forecasting. Demand side management is also doing the. Recently, most of the researchers, they are focusing for demand side management. So also the good topic. If you go for MTech, if you go for research area, demand side management is also the good topic. Risk and uncertainty modeling is also doing operation as well as planning also. So these are the power system optimization problem which can be handled in operation as well as planning. Okay. Now, so general positive, what are the general positive we have to solve in GAMS basically? First thing is problem. What are the problem of related? Means if you go for the unit commitment problem, let us say, so they are having some problem formulation. I mean, it having startup constraint, it having a ramplet limit, it having power generation limit, whatever they are constrained, they having the problem. Then we have to mathematical model. We have to model this problem. Okay, then we have to solve the solver optimization. Solver optimization means whatever we are solver we are using. It may be linear programming, it may be non-linear programming, it may be quadratic programming, whatever be the solver optimization we are taking, then we have to get the solution. So these are the general procedure which have to follow the basically research work in GAMS. Okay. Now, let us say we are taking some simple example. What are the objective function? We have to objective function. We have to maximize or minimize, or let us say the function of x. Okay. So function of x, whatever be the function of x we are defining, it may be x1 plus x2, it may be x square plus 2x, whatever the quadratic equation are there. What if you say the linear equation, that is x1 plus x2. If you say mixed linear non-linear programming, then x1 square plus x2 square. So objective function we are defining as, let us say fx is having constant, that is equality constant and equality constant. Equality constant means that is g is equal to 0. If you say inequality constant, it may be greater than equal to 0, or we can say less than equal to 0. So we are defining inequality constant, that is hs is greater than equal to 0. Just we are taking the example, means what we are clear to general optimized problem in GAMS. Okay. So these are the types of optimized problem. First one is linear programming. Then we can solve the mixed linear programming. Then we can solve the non-linear programming. Then quadratic concept programming and mixed linear non-linear programming. These are the types of optimization problem which can be solved in general way. If you solve large number of constraints you have large number of objective function. So these are the solver which can be used in optimization problem. Okay, these are mathematical optimization problem which can be used in general GAMS solver. Okay, so these are the solution technique. We have to consider which type of solution technique we are taking. First of all, heuristic technique, as already earlier I am already said that AI technique we can say, and another is a classical optimization. Classical optimization is nothing but is the GAMS. That's we are done in classical optimization, but in holistic technique, most of the researchers they are doing PSO, simulating alanine, seeker, cuckoo search algorithm, taboo search, whatever they are. These are the different types of GA technique. So these, if you go for GA technique, they are having some power system problem in different population. It depends on population. They are the try to improve it by using some operation. They modify the population solution. For example, GA use the crossover and mutation operator to improve the solution regarding optimizing the objective function while satisfying the constraint. So the heuristic technique having some iteration solution. We have to iterate number of iteration in heuristic. But in classical optimization, you have to give the optimal solution. If you say if you take the linear programming, that interior point method, or we can say branch and branch method, Bender decomposition, these are the different classical optimization problem. If you solve in GAMS, then you can give the global optimal or particularly optimal solution, because they in heuristic they are having large number of iteration are there. So that's why we are going for classical optimization to reduce the time. Main important is that this is the execution of time reduction. We have to reduce the time. So we need the classical optimization problem. So that's why we are going for classical optimization problem. Is a good solver. If you go for the GAMS, I will show you some example of how can you solve the classical optimization problem in GAMS. Okay. So if you go, when we are going for GAMS algebraic modeling system, there are some discussion. These are the formula. These are the form of general modeling system. If you click www.gams.com, if you written in Google site, then these are the World Bank. You have Washington DC, USA in 1981. He can be published, and it having large number of materials. If you click on those GAMS side, you get the GAMS user guide material, and by using this system, you can use and follow all the instruction how the how can you install the GAM and how can you model the GAM. So whatever, so they are having some example are also having. So these are the learning oriented modeling language which can be used in GAMS also. GAMS at a glance, it can be used in the lots of model template. They can be used in development interface. They are the mathematical problem, and these are the simple for design principle. These are the designing of GAMS. Again, if you go for the, if you open the GAMS solver, then it will show at this way. These are the picture of GAMS which can be used in optimization problem. So whenever using the GAMS installation, if you install in our PC, first of GAM installation. So these are the platform. If you install in 32-bit also, it can be installed 64. If you have 64-bit, then 64-bit also. So these are the installation way how to GAM install in your PC. So this is if you have license copy, license file. Basically, we have license file because in MNIT Jaipur they are purchasing the software of GAM installation and they take the license file of them. But if you trial version, you can run the program most of the variables. Okay, you can solve this. Means if you have short most objective function, if you have more than solution, then it can be easy to solve. So these are the GAMS solution which can be used in the power system optimization problem. Okay, now these are the pictures of when we open the file. They are the finding. These are the match partitions. These are the print, and these are the run GAMS. If you run the GAMS, then the output will become. So when we open the GAMS, this file will be open. These are the file picture, and you have to write the program. What we are code you have, what is the objective function, what we have set variables, whatever we have. Okay. So these are the opening of GAMS interface layout. So these are the solver which can be used in GAMS solver information. Basically, most of the researchers, they are doing for simplex solver. So simplex solver, as we know, most of the programming doing simplex, that is MIP, mixed integer programming, or we can say mixed integer linear programming. If the system, if the objective function is linear, or we can say the simplex solver, that they are using the simplex solver GAMS solver, which can be used in the system. So these are also the programming which can be used in the GAMS solver information. Okay. So now, these are generally modeling system in GAMS language, which can be used. It as the part of the source sheets. It can be say the GAMS tutorial in broker, or these are GAMS user guide. As we already said in RE Rose channel is the book, key book. You can follow this book and you can learn most of the things of GAMS modeling system, how to model the GAMS solving system. So these are the system of the part of GAMS modeling system. Okay. Now, before going for GAMS, these are the general characteristics. What are the democratic texts we can say? Because if you talk about if you write anything, so we have to $sign, on text or off text instruction, or error having. If you have error part, when we run the program, they're having some error. We have to error, and error having indicates point and compiler found error. So they're having some error point. If they are started founding, they are having some error in general characteristics of GAM. Okay. So what is the organization of GAM program? First of all, we have to learn about how to indicate those GAM program, how to follow the GAMS program. First, we have to declare the data. Data means it may be having set, it may be having parameter. Parameter means we have parameter declination, assignment, display. Now model means variable. We're having some variable that is x1, x2, whatever. Equation, we have to decline the equation, then model, then last one is solution. So these are the organization of GAMS programming. Okay. Now, what is the basically general structure of GAMS code? First of all, this is the general part. How to use the GAMS code in our solution. Okay. So first we have to define the sets. Sets means if having number of generator, it may be 1, 2, or 3 generator. So we have to define the sets. Next, we have to define the variables. Variable means is the unknown variable. It may be positive variable, or we can say negative variable. Then we have to define the scalar. A scalar means if you having demand, means if electrical engine system, if you have demand, whatever the load you have giving, these are the scalar. So these are a single point of value, that is scalar. Parameter means it may be defined on parameter. We have given some data in table also, or we can define in parameter also. Okay. Now, then we can write the equation number 1, then equation number 2, then equation number 3, and equation number 4. Means you have a number of equations. Means equation number 1, let us say objective function. Equation number 4, let us say inequality constraint. Equation number 3, let us say equality constraint. So these we are defining the in a way of equation. Then we have to model. Model means we have to model in means let us say all, means we have to take all the equation or variables or say scalar or parameter. So we defining the model, and then we have to solve. Solve means if you have solver of any problem, that is linear programming, or we can say quadratic programming, or we can say linear, non-linear, whatever we are taking the solver. These are the solution technique. Okay, so these are the structure of input, structure, then output. So these are the general structure procedure how of the GAMS code. When we are taking any problem, if it may be mathematical problem, linear programming, if it may be economic dispatch or unit commitment, whatever we are problem taking, we have to follow this instruction. And these are the structure we have to follow the general procedure of GAMS code. Now, so basic component of GAMS code, these are the basic component, that is comment, then sets, then data. We have to take some data. Data means whatever be the data as a maximum data, load data, or we can say generation data, or we can say coefficient data. These are the data. Then we have the variables. We have to define some variables. Then equations. Then models. Then what are the solver you are using, and then output. Okay. So these are the basic components of GAMS code. Now, first of all, what is comment? Comment is the basically line. These are the notation of comment. When we're starting the comment now, just we can write economic dispatch problem. Just like you can return. These are the comment. Okay. And when we're defining the set is the element of array. Means I already said that if you have 3 generator, or we can say 10 generator, so we can write set 1, 2, 3. We are having, if you have 3 generator, then we can write 1, 2, 3. So you can also write 1 into 3, 1 star 3. So it can be it will be take easily. Okay, so set can be if you comment of one set, you can define 1 is to 3 also, or 1 to 3, whatever. If you have large number of generator, if we say 54 generator, so we can write 1 star 54. Then we have to give this bracket and then semicolon. So this is the way of how to define the set. Okay, now, so I am giving some example. Suppose that oil cooled oil type light and heavy. These are the 2 oil. If you say oil 1 and oil 2, they are having 2 oil. And if you say the product of refining, so we are defining the product 1 and product 2. Okay, so semicolon. Do not forget this, because if you do not give the semicolon, they are having some error. So these are we have to follow the instruction of oil. If you go for product, so we have to define in this way of set. Now, how to write input data that is a scalar. Scalar, we have to define the quantity. We can say the demand, or we can say load, whatever we are defining. So we are defining the scalar in this way. Scalar Q to total refining capacity, that is 15,000. We are defining just a simple example we are taking, that is we have to say in scalar in this way. If you define in parameter, then the parameter decay product demand will be product 1 or product 2. Product 1 having the parameter value with this, and product 2 parameter value of this. You can define also in table also. In parameter, you can define also. If you define in parameter, you having choice. So table PGK, unit of crude oil per unit of product, that is oil 1 and oil 2, and product 1 and product 2. In this way, we have to define this table also and parameter also. Okay. So these are the syntax of GAMS statement. How can you define set element? How can you define the subset? How can you define the index? These are the this we are showing the GAMS statement. How can you define? Let us say, if you say set index, or we can say set, or we can say index, they are having A, B, C, and D. Okay, so we are defining just a set as A, comma B, comma C. As we say earlier also, how can define the set? So if you have 3 generator, or we can 2 generator, or we can 4 generator, you can define A, B, comma C. Syntax set name of set. You can set the name of set. Whatever your set name means, if you can, the name of set is generator. If you can say or name of load, so what is the name of set, and we can write the element. Now If you talk about the time period, if you talk about the time period that we are indicated in and giving the set data T1 is to T24 because we are taking the 1 to 24 scheduling of time. Okay. Now we are taking the number of generator, that is G. We are defining the G, or we can also, you can also define as I. Okay. So we are defining G. G is the number of generator, and you can write G1 star G10. Okay. In this way, we have to define the set. Now multiple name for alias. Alias means if you're having bus connected, means suppose that in bus number 1 they are having line 1 to 2 connected are there. So he can write set I number of buses, bus 1, bus 2, and bus 3. Alias means I node to J node. Okay, so these are the connection of I to J, means node 1 to node 2. They're having some line. If you had take let us say number of power system, you have done lots of work in theory also. So they are having transmission line data. The transmission line data is at line 1 they are having node 1 to node 2. At line 2 they are having node 3 to node 4. So these are the alias. Alias means one node to another node. So these are the subset of those aliases name which can be said in set. You can also define an alias statement. In subset, we have to define light mode, IT, tether sector, or NT, which can be used in the heavy node. So these are the index of GAMS statement. Now we have to define the scalar. Scalar means I already tell about what is scalar. Scalar is the single scalar data entry. Single scalar means they're having some load data, or we can say demand data, whatever we have, they are the scalar quantity. Parameter, I will already say how to define the parameter. These are the parameter. Suppose that P minimum G, that is minimum power of generator, that is G1, G2, and G3. This is the way of how to define the parameter. If you define the demand, scalar is the demand. There is single data. So PD is the system demand, that is 120. If you define B as a suspend of transmission line, so you can define minus 0.13. This is also the way to write the scalar way. How to write in the scalar way, how to write the parameter way, and how to write the table way. Table, that is I1, I2, I3, and I2 and I3. These are the connection of coefficient, and these are the way we have to write in table also. So these are the data entry, how to write in GAMS. Now we have to write the variable. Well, these are the way we have to go for the step by step. First we have to write the set, then we have to write the scalar, then we have to write the parameter, or we can say table, then we can write, then we have to write the variables. So variables means variable means whatever defining the objective function. It may be the fuel cost, it may be the whatever we are defining the objective function. So we are defining TC. TT is a total cost. Total cost means in the next slide I will show that how we can define the total cost. TC is the total cost. Positive variable means it may be the positive or negative. So we are defining PG is the positive variable. Or if you talk about the variable bonding, they are having two bonding, lower bonding and upper bonding. These are the lower bonding, means they are having some generator P minimum and P maximum. If we say P minimum means 10 megawatt, P maximum is the 50 megawatt. It may be varies between P lower and P upper. So we are writing this value in this way. PG lower, that is G1 is 10 megawatt, and PG upper G1 is 85 megawatt. It can be write in GAMS in this way. P minimum, or we can say the P maximum. So these are the way of variable bond, and del is delta fixed. That is bus 1 we are taking the 0. That we say already in you are already done in power system, that is slack bus. So we are slack bus taking as bus number 1, that is 0. This is the delta flex. Okay. So these are the variables. How can you define these variables? Okay. Now what are the basically these are the types of variables. This can be declination. Okay. Attributes, lower bound of variable. Dot LO is meaning of lower bound of variable. Dot F is the upper bound of variable. Fx is the fixed value of variable. These are the, and dot L is the active level of a variable. Means if you display the value, then dot L is the most important things. Means if you display the generator, that G1 dot L, so G1 you got the value of G1. If you get the value of objective function obj dot L, so we will get the objective value. So these are the display of the dot L. Okay, so these are the variable attributes which can be used in our GAMS solver. Now how to write the equation? These are the most important. How to write the equation? First of all, we have to, let us say example, objective function. We are writing the just a simple objective function. You can write as you know, as you wish. You can write objective function, or we can write the TC, or we can whatever you can like. So we are writing this equation is objective function. Objective function, minimization of total cost. We have to minimize the total cost. Now we are giving the supply demand, the supply demand equality constraint. Okay. Now let us say the objective function. Let us say these are the objective function. TC is equal to I belongs to A, means summation of I to tends to A, means number of I generator taking the number of nth generator of 2. Okay, so I is the number of generator, AI plus BI PI plus CI PI. So this is the ABCI is the coefficient of generator, and PI the power of generator of ith. So we are taking just a simple example. How can write this equation in GAMS? So we are writing just like objective function we are taking, as we earlier said that objective function we are taking. So objective function, then dot dot dot, then TC. TC is the total cost, and E is the equality constant, because if you write in GAMS now, we have to write the E. This is the main code. E is the equality, is equal to sum I we are taking this I, comma AI plus BI PG I plus CI PG I into PGI. So these are the way you can write this equation in this way in GAMS. Okay, if you write supply demand, because summation of PI is equal to PD, and supplier is equal to demand. So obviously supplier is equal to demand. Then we can write in this way: supplier demand equality constant, that is sum of I comma PGI equal to E or equal to PD. So in this way we can write the objective function as well as supply demand. So E is nothing but it is the equality constant, and G is the, if you having greater than equal to, then you can write greater than equal to, G greater than equal to. This is the notation you can write. And if you have less than equal to, then you can say the less than equal to. So these are the way we have to write in this way of the equation. How if you have equal or less than or equal, whatever greater than, then this is the way of write the equation in GAMS solver. Okay. Now we have to model. Model means we have to model all the things. It may be we are in first step to last step. First we have to take the set, then we have to take set scalar, then parameter, then table, then variables, then equation. So all those things we are collecting constant and variables. So we have to take the model. Model name, whatever you have choice, you have name of model, whatever your name means. If economic dispatch ED, you can write. You can also write unit commitment UC, whatever you like. So let us say I am saying the example model economic load dispatch all. All means we are taking all those variable, constant and variables, means set, variable, constant, table, parameter, whatever. So we are taking this collection of data and variables. So these are the model. These are last step. And the last one step is solve. We have to solve those model. Solve model name, already we have written the model name, and we have to maximize or we have to minimize. What we are considering the means in equation, it will be maximize or minimize. So we have to solve those solver. So let us say example, solve economic dispatch problem using NLP, minimizing total cost. Why we are minimizing total cost? Because we are taking the objective function TC. We have to minimize this objective function. Try to understand this problem. We have to minimize this problem. So that's why we are writing economic load dispatch using NLP, linear program, non-linear programming, because they are non-linear, because they are square. That's why we are taking the non-linear programming. So that's why I am writing the economic load dispatch using non-linear programming, minimization TC. This is the way to solve the problem of GAMS solver. Okay. So these are the steps we are already study, and these are the model we can be solving statement. So these are the model type: linear programming, MIP, mixed linear programming. These are linear district, NLP programming, mixed linear, non-linear programming, QC programming, mixed linear, quadratic programming, and so on. So these are the model type which can be used in the economic load dispatch problem, or we can, whatever your problem you can say. It may be you can take linear programming. Linear programming you can solve, this is no problem. Then they are not having PG square, only PI. So we can go for linear programming. So these are the most structure. These are the suitable structure you can have to follow in GAMS solver. Okay. Now let us say some example. We are taking simple example of GAMS. First of all, there is linear programming. A person has $10 to spend on apples and oranges. Every rupee spent on apples being 2 units of happiness, where each rupee spent on orange brings 3 units of happiness. Optimize the amount of money to maximize the happiness. We have to maximize this problem. So maximize of x comma x0 2xa plus x3 x0. They are having some inequality and equality constraint, that is xa plus x0 less than equal to 10, or xa greater than x0, or x0 greater than x0. So these are the constraint and which having objective function we have to maximize this equation. This is the question. Okay. Now how can I solve this problem in my GAMS? So these are the notation of GAMS code. Okay. So these are the variables. We have to define z objective variables that to be maximized. Then we have to write the variables, that is xa. You can see this equation xa and x0. So we are written xa is as the amount of money spent on each other of apples, and x0 is the amount of money spent on each as orange. Apple and orange ka having already given is the value. So that's why we are writing this value xa and x0. Now we are defining these are the variables, these are the positive variables, and these are the equation. Now we have to define the equation. How to define? In the earlier slide, we already say we have to write the objective function, ob underscore function. We can write objective function of a problem. Inequality constraint. We are assuming we are writing inq underscore constant. You can write your choice. If you write objective function means obj, it doesn't matter. When we are writing obj, you have to write in there here also. Okay. Inequality constraint, you can write ineq. You can also write it will be take. GAMS will be see the program. It doesn't matter. Okay. ineq underscore constant, we can write inequality constraint. So objective function we are defining dot dot. These are a declaration of GAMS code. Objective function dot dot. Z is equal to, Z is the variables. Z is equal to E. That is we are taking already in the question we have E is equal to 2xa plus 3x0. So we are writing 2 into xa plus 3 into x0. We already written this in the GAMS way. If you go for inequality constraint, that is next equation is that xa plus x0 less than equal to 10. Here we say xa plus x0 less than equal to 10. So we are written xa plus x0 less than equal to 10. Now we have to model. Model means we have to model all the things, means variables, positive variable, all the things. So model, we are write the name, just we are written the name example number 1 and all. Okay. Then we have to solve this example using linear programming. Why we are using linear programming? Because these are all the program, all the function equation are linear. That's why we are writing the linear programming. Okay. So linear programming maximizing the profit. So these are the value. So these are the output of the result. These are the output of the result. I will share this slide. It is still all of you. I am audible. Hello.
Yes, sir, audible, sir.
Okay. These are the variable you can define in this way. So z objective variable that to be maximized and positive variable we have to define in this way. So if you run this program then you have to give the objective function. Let us say if you click the solve bar, there is z value. Z value having the value where we say the z value. Z is the 30. Please mute yourself in the background so that I will explain. If you click Z value now.
Sir, sorry to interrupt.
Okay. Yes.
Sir, sorry to interrupt, but your slides are not visible.
Okay. Just wait.
You are audible.
Okay.
But
I'm just sharing. Okay. Just wait.
Not visible. Yeah. Now it's
Just wait. It is audible? It is audible? So
Yes, sir,
these are
you're
the
audible.
example we are saying that
Yes, sir, you're
as
audible.
already. Thus, these are file we are opening in GAMS solver. Okay. First, we have to write the variables, that is Z objective variables that have to maximize. Then we have to write the positive variables, that is XA and X0 as the question is concerned. And then we have to write the equation, objective function of variable and equality constant. And objective function, we have to write the objective function dot dot, that is Z is equal to E 2XA plus 3X0. If you write inequality constant dot dot XA plus X0 less than equal to 10. If you model all these problems, we have to write this all. Please mute yourself. Okay. Then we have to write the model. Then we have to solve the example number 1 using linear programming. If you run this program now, then you got this value. This is the Z value, 30.00 level, and XA dot X0 is 10. So these are the value of we are getting in this problem. Okay. So these are the problem which can be used in the GAMS solver. Okay. Okay, I am here now. So these are the value. These are the Z value. We are giving
Sir,
30 point
slides
value
are
and
not
X and X.
visible.
Not visible.
No, sir, it's not visible.
Just wait. Now it is visible. Hello. Now it is visible.
Yes, the side is visible. The side is visible
Okay,
now.
okay. Okay, I'm
Yes, sir.
starting.
Yes, sir.
Again, I'm going for against platform so that it is visible. Okay. In here we can GAMS output. We are getting some result. When we are solving this example number 1, so we got the result of this. We have to model solve Z, then XA and X0. These are the display of value. These are the display value. We are defining the variables. So these are the variables. We are getting the answer, that is Z, that is objective function, then XA and X0. So these are the simple problem we are done in GAMS solver, how to solve those problem. Okay. Now these are the output. If you go for next problem, that is QCP, quadratic constant programming. Quadratic constant programming, if you go for, so these are the simple equation we are taking, that is we have to maximize the objective function, minus 3x1 square minus 10x1 plus x2 minus 3x2 is having two constant, that is inequality constant, that is greater than equal to or equality constant. So we have to write this equation in the GAMS. Okay, they're having no data, so we have to write first of all variable, that is variable objective function. We have to take OF x1 and x2. See, in this equation we do not having set, we do not having scalar, we do not having data. We have already having equation built. So we have to this equation we have to maximize this problem according in QCP. Okay. So we have to define the variable. First of all, we have to define the variable, that is OF, that is objective function. Then we have to define x1 and x2, because we have to find out the value of OF and we have to find out the value of x1 and we have to find the value of x2. Now we have to write the equation in this way: equation 1, equation 2, and equation 3. So how can you write equation 1? Equation 1 you can write in this way: minus this minus 3x1 square. You can write in this way: equation 1 dot dot dot, or we can write anything anyway. You have a choice. Equation 1 you can write EQA TI1, whatever you like. I am writing this in this way: equation 1 dot 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 minus 3 into x1 minus, you can write also here, if you write 3 star xqr into xqr x1, you can write all here also. I am writing in this way. That is the very simple way, that is minus 3 into x1 minus 10 into x1 plus x2 into x2 minus 3 into x2. In this way I have already written this equation number 1 is equal to objective function, because these are the equality constant. That's why we are writing E. Okay. If you go for this equation, we are writing equation number 2 dot 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 x1 plus x2 into x2. G is the greater than equal to. So we are writing G. I have already say about that. If you are greater than equal to, then we can write G. If you are less than equal to, then we write the L, not I, L. Okay. So x1 plus x dot dot x2 into x2, G is equal to greater than equal to 2.5. If you go for equation number 3, then 2 into x1, that is 2x1 plus x2 equal to 1. We can write 2x1 plus x2 equal to E equal to 1. So in this way, we can write this equation. Okay. Our model QCP, if you model this value, QCP all means you have to model all this value, and we have to write this QCP by maximize. So when we are going to solve this problem, I'm not giving in this result. You have to write in this way. Okay, I'm not showing the result because the slide will be, I think so, this will be deleted the slide. Okay, in this way we have to write in QC programming. Now, when we are power system people, so we have to know about the economic dispatch and unit commitment problem. Okay, so first thing is that what is economic dispatch and what is the main importance in power system optimization problem. See, economic dispatch, a power system having different power plants, have several number of units. Okay, so we have economic dispatch, basically that is we have to control those demand power output of each power plant, and we have to minimize those overall cost, means that is fuel cost, to meet the system load demand. Means we have to minimize those objective function, that is the fuel objective function, fuel cost objective function, and with having those objective functions, we have to satisfy all the constraint. That means we can say supplier is equal to demand, or we can supply is greater than equal to demand, whatever we are saying. Okay. So these are the way which can be used in economic dispatch function, and these are the cost curve, input output cost curve, as we already studied in most of the BTech student already study about what is P minimum, P maximum, values of the these are the cost function, increment cost, and these are the PI, the output power in megawatt. So economic dispatch problem is the main objective is that we have to minimize the cost, fuel cost. Okay. Now we are going for just for problem formulation. So what are the problem formulation of this economic dispatch? That is CPGI, PGIT, PGPGIT plus CI. These are the AG, PG, CG are the coefficient of all the generator. G is the generator and T is the time, and P is the active power generation at time T. So these are the fuel cost function. CPGIT is the cost function of fuel cost function, or we can the production cost of thermal unit. If you talk about the total, if you go for the total fuel cost, you can get right in this way also. TC equal to summation of G comma T CPGT, means we have to sum of all those things. So we can write in this way also. Total cost is equal to summation of G comma T CPGIT. If you minimize the total emission, we are taking also the emission objective function, emission means data also. The emission we can write G comma T DGPGTI plus EGPGIT plus FG. You can write in this way emission. Emission is the equation of emission. DGP, EGP, FG are the coefficient of emission of generator G, and P is the active power of generation T at time T. So by according this objective function, they are having some limit, they are having some constraint, that is operating limit. As we know earlier in BTech class, we are already run that PG minimum is less than PGT as less than PG max. So they are having 10 megawatt or 50 megawatt, we have to maximize PG minimum or PGT or P minimum. This is the operating limit. Okay. And they are having ramp up limit also, ramp up and ramp down. So these are the constraints which have to write in GAMS. So these are the objective function. We have the overall thermal unit cost based economic dispatches. TC is equal to, we have to minimize this AGPGTI, BGPGTI plus CG. So we have to minimize this cost function, that is fuel cost. My main criteria is that we have to minimize this cost function. So according to this cost function, we having some data. We are just considered the 4 units example, J1, G2, G3, and G4. AG, BG, CG are there are 4 cost coefficient are there. AG, PG, CG are given already data inbuilt. DG, EG, FG already given data. P maximum already given data, and ramp up and run already given. All data will be given. So first of all, according to GAMS, we have to write first of all the set. We have to define the set. Set is T hour, means T1 to T24, because we have to define a tower time. Then we have to then we have to define the units, that is thermal units, that is G1 to G4, because we are taking this 1 to 4 generator. So we are defining the set as a G1 dot G4, or we can write G1 comma G2 comma G3 comma G1 as you wish. You can write also on those way also. So I am writing this I thermal units G1 star G4. Now we are defining table generator I comma star. I comma star means all the data we are taking, that we generator cost characteristic means we are taking already data here. We say already table here that AG, BG, CD, DG, whatever we are data. So we are taking this A, B, C as a coefficient, D, E, F as a coefficient, P minimum, B maximum, and M down. We are already taking the given. Do not forget the semicolon. Always write the semicolon. If you plot the, you will set the data now, you have always write the semicolon. Okay. So these are the way how to write the generator. Now we have some parameter, that is demand. Demand is forecasted demand. We are taking some demand, that is T1 to T24. We already given data. Okay. Now, how to write the variables? How to write the variables? So variables we are defining objective function. First we have, because we have to minimize the objective function. So that's why we are writing OBJ. Whatever you like, you can write also in TC also. You can write TC, ABJ, whatever you like. Okay. GAMS, no problem. OBJ, we are taking OBJ. Now we can write PIT. PIT, power of generator I at time T. So that's why we are writing PIT. And then we can write emission. Emission cost coefficient, that's already given in the question. That is emission. Now we have to write the equation. After the variables, then we have to write the equation. We are writing equation in generator cost 3. We can write equation number 3, equation number 4, equation number whatever we will like. I am writing this generator constant 3, constant number 3, constant number 4, constant 5, constant 6, cost thermal calculation. Means we are just indicating this objective function in the way of cost thermal calculation. Then we have to write the balance. Balance means supply equal to demand or greater than equal to demand, whatever we like. Balance. Then we can write the emission calculation. Okay. So in this way we can write equation. Now cost thermal calculation we are written already here in equation. So we are writing here cost thermal calculation dot dot dot. Then we can write objective function in this way. As we already saw, the sum of T comma I, as we say in this equation, we can say already A comma sum of T comma I, because time is go for I. So sum of T comma I we can write. Then generator data I comma A cap, because A is the coefficient, into power. Power means square. We can write in power way also, or we can write PIT into PIT, whatever you can write. I am written here power PIT comma 2. Then we can write generator I comma B PIT. Then we can write generator I comma C. In this way, the objective function we can define. Okay. Now the balance is second question is that second equation is demand is equal to generator. I've already seen now demand equal to generator. So demand we can write the generator greater than equal to demand. Emission calculation we already given the data T comma I, generator TD TEF. We can write in this way. Similarly, objective function you can write also in this way. Then we can write generator constant 3, that is ramp up and end down. These are the equation we can write also. PIT plus 1, PI minus T, generator data I comma RAM. PIT minus 1, PIT, generator data I comma RAM. P minimum and P maximum you can also write. Here the equation you can also write in this way. Okay, so we are clicking in this way, PIT, generator data, PI min and P max. So we have to model this equation, and we have to model all. All means we have to set data, whatever we are defining the parameter, whatever we are defining the equation, whatever we are defining the variables, we have to model those equations. That is, we have to model all the equation. Then we have to solve. We are taking the name economic dispatch based QCP minimum. Because why we are writing QCP? Because these are the non-linear. Or we can also write NLP, whatever you can write. NLP is also the non-linear programming. QCP is also the quadratic programming. That's why we are rating the QCP. Minimize means the minimize the objective function. So these are the way to write the economic dispatch problem, how to write the simple problem of economic dispatch. And when we're solving this problem now, we have to get the result. These are the GAMS output. Objective is this value, this is the optimal value. That's why we are going for GAMS. These are the optimal value, and these are the power of each generator, G1, G2, G3, of time 1 to time 24. So these are the scheduling value of it, because economic dispatch nothing but we have to schedule the output of power generator. So these are the output of power generator. Okay. So these are economic dispatch problem, and these are the result. Result means when we are getting this value now, G1, G2, G3, G4, we have to plot this all the value in T1 to T24. I am plotting this value in MATLAB. Means whatever we are getting the value of T1 to T24, we are just put the value and plot this curve. And these are the demand data. Yes, we are forecasted data we have already said about whatever we are taking the demand data. And these are the generator power output. So these are the simple problem of economic dispatch. It is all clear or not? Any problem? So that कोई किसी को problem? Yes, I am audible, all of you. Hello.
Yes, yeah,
Yes.
yeah, sir, you are all.
Okay. Now, when we are integrating the wind, when we integrate the wind integrated economic dispatch, you can also add the wind power. Means we are adding just our objective function economic dispatch plus wind curtailment we are adding. So similarly way we have to write this equation, and we have to write the wind power, wind curtailment power. Okay. So by using this wind integrated problem, just same example, same are there, same data are there. Okay. We have to add only the wind data. I am already adding the wind data, and by using this we have to, these are the same problem we are written. We have to add only the sum of T VWC into PWC TT. Okay. So wind curtailment into wind power. So we are already given VWC is a scalar, that is 50, already given. Data is already given. So by using this, we have to solve this QCP. And last one is display. Display is the, we have to display all those things, means cost, or we can say power, or we can say power curtailment, whatever the variables you can define, you can display also in GAMS. Okay. So these are the output when we are defining the wind. Means when we are adding the forecasted wind data, then the cost will be this. We can see there the objective function will be reduces as compared to without wind. If you go for without wind, now we are not, when we are not considering the wind, then the objective function will be higher as compared to wind when we are considering the wind. Obviously, if you add the wind, the objective function will be reduces. So objective function will be reduced, and cost and all the generator function, all the 24 hours also reduces. So these are the cost and also the power generator of thermal of cost based economic dispatch. And these are the graph of power generator, that is G1, G2, G3, and G4. All the generator when we are getting those value, these are the generator value. We are putting this value and we plot this curve. And these are the thermal power value and load and power curtailment. So we got the result of this power and as well as thermal value. Okay. So these are the result of wind economic dispatch problem. Okay. Now, before going economic dispatch, now we have going for unit commitment. And what are the basically difference between economic dispatch and UC? That is the most important question. Economic dispatch having we have to minimize the cost, but in unit commitment we have to minimize the cost, and also we have to minimize the startup and shutdown cost. We have to minimize the startup and shutdown cost. So that's why we are going for unit commitment. Unit commitment we have to solve problem by mixed engineer programming, because unit commitment is nothing but once when the generator is on and the generator is off, depends on whatever we are taking the data. So unit commitment is basically the which generator is on and which generator is off. It depends on the student data. So that's why we are taking the unit commitment problem. Unit commitment problem basically, when we are solving this problem, according to GAMS, we have to go for MIP, because mixed engineer programming, because these are the discrete or continuous variable. That's why we are rating the MIP, mixed engineer programming. If you go for economic dispatch, you go for QP, that is quadratic programming, or we can say non-linear programming. So that's why we are taking the MIP. So the unit commitment problem is the most important, or when we are going for non-linear programming, that is MINLP. So these are the addition, MIP plus NLP, that is the MINLP, that is mixed engineer non-linear programming. If you are having non-linear data also, if you are having integer value also, then we go for the large scale problem. If you have large scale complex problem, non-convex mixed engineer non-linear programming, then we talk about the mix is a non-linear problem. That is MIP plus NLP. Then we can write the MINLP. So these are the unit commitment problem, and ED dispatch problem. This is the main difference between about the unit commitment and economic dispatch. So what is basically unit commitment? As I already say about the unit commitment, basically the unit which unit is on or off. It depends on shutdown or startup cost. So the unit commitment we can solve the problem in week also, month also, or year also. So these are the objective function. In earlier slide, we already studied the economic dispatch. That is the fuel cost. So we have to minimize the fuel cost also. We have to minimize the startup cost also, and we have to minimize the shutdown cost also. So these are the objective function of economic unit commitment. And these are the constants. Similarly, constants are there. These are the constant of P minimum, P maximum. We already said about, so we do not repeat again. So what are the challenges regarding of unit commitment? Basically, these are they are having two parts: the conventional unit commitment and deregulated power system. So unit commitment divided in two parts, that is SCUC and PBUG. SCUC means security concern unit commitment, and PBUG is price based unit commitment. SCUC basically depend on system operator, where the system operator deals the deregulated power system. Means SCUC perform the deregulated power system and is to minimize the operating cost or maximize the security with having some prevailing constraint. So SCUC always perform the system operator. But if you go for PBUG is a price base. We are saying the price base means it depends on electricity marketing, where the GENCO bids the price or send the price. They are depends on PBUG, that is price based unit commitment. So most of the researcher they are doing in today life, that is PBUG and SCUC. SCUC, I have done my research work in SCUC. My objective is we have to minimize the cost in deregulated power system criteria. That is my objective. So I have done the in research work SCUC, that is stochastic security concern unit commitment. Stochastic means this is a multiple problem, and deterministic means there is single problem. I will go for in the next slide. So SCUC we have to minimize the cost, and PBUG we have to maximize the profit. So these are the classical area when we are going for unit commitment. You can see most of the research work in 1990, 89 to 2020. Still, most of the paper means you can say 10,000, 20 lakhs paper are there in unit commitment. Okay, when the deregulated power system is come, then the number of problem in SCUC, because deregulated power system is basically the process of removing or reducing the state regulation, means is the re-regulation. When the system will be going re-regulation, the system in already market, then they are having some competition. So they are the deregulated power system. So deregulation is nothing but is the process of removing or reducing state of regulation, typically in the economic criteria. It is the repeal of government regulation of the economy. So we can say the deregulation. Most of the in the earlier 2001, since 2001, most of the system are regulated framework. But today in monopolies came for all the deregulated criteria. All generation company, transmission company, system company having own monopoly. So they are deregulated. So that's why we are going for SCUC problem in deregulated power system. And we have to minimize those costs in SCUC problem. So these are the basically criteria of SCUC. Now SCUC having two parts, most of the problem we can see in research paper article, SCUC having dividing master problem, sub problem. We do not go for this way because these are the vast area. So that's why we are not going. These are the three parts, GENCO, TRANSCO, and DISCO. These are the calculation of how to calculate the SCUC problem. Now, what are the main objective function of UC? We are already said that the economic dispatch problem. Now we going for the economic unit commitment problem. So unit commitment problem, they have to minimize the number of generator, that is 1 to number of generator, and T is equal to time. And they are the objective function, that is fuel cost into UIT. UIT is the commitment structure. UIT we are defining here. Here we are defining UIT. UIT means the commitment structure. Which generator is on and which generator is off. It depends on binary variable. It may be continuous discrete variable. So we are writing the UIT. ST is the startup cost and ST is the shutdown cost. By using this constant, we have to satisfy all the constraints. Generator capacity, as we say on dispatch also, but here we can write only UIT. We are adding the UIT. UIT and system power balance is PI UIT, and forecasted wind is equal to demand. And they are having system spinning reserve requirement. Means we have also taken the reserve requirement. We all means you had large number of constraint. Means GAMS is the solver is if you had number of constraint. Means it may be spinning reserve constraint. It may be the regulation constraint. It may be the reserve constraint. Whatever we were adding, marketing constraint we also add. So if you add large number of constraint, whatever depending on the problem, it depends on problem. Whatever we are taking the objective function. So we are taking this just a simple example. These are the objective function, and these objective function they are having some constraint are there. So by using this problem, we have some data. Sorry. Also, we are taking. They are having also constraint are there. Minimum up and down constraint are there. Ramp rate limit are there, and there are some other constraint are reserve constraint, emission limit. Already say about transmission line also constraint. Transmission line means it may be the DCOPF, it may be the ACOPF, or we can say these are the transmission line constraint. Okay, reactive power constraint, voltage transformer transfer limit, whatever be the constraint we are taking. So the GAMS solver we can easily solve. Okay. So we are taking the simple example that is 6-bus system. These are the most important example, easiest ways example which can be used in our system. Okay, so we are just taking the system 6-bus system. Okay, and these are the table of generator data. These are the coefficient data, and these are the load data, load and forecasted wind power data. So these are the data we are taking. By using this question, we are just put our value in a similar way, but we are adding the some minimum up and down. Means we have had some constant are there. In earlier economic dispatch problem, we do not have minimum up and down constant. So we are adding minimum up and down constant. We can define the sets of minimum up and down constant. Okay. And generator data, similar way, we can write the generator data. Demand, we can also write. And these are the variable, fixed, that is total cost, power, UIT we are adding. UIT is the commitment status, which generator is on and which generator is off. So we are just writing this UIT. Then we are writing YIT, that is startup cost and shutdown cost. So in the earlier slide, we are defining the economic dispatch. But when we are going for unit commitment now, we have to define the unit commitment, that is on-off status, startup and shutdown. So we are written minimum up and down time also. So these are the binary variable U, Y, and Z. Obviously, because these are 0 and 1 binary variable, so we can write binary variable U, Y, comma Z. These are the extra addition we are taking in unit commitment problem, U, Y, Z. And these are the equation we are defining. So these are the equation. In the earlier slide also, we are already written how to write the ABC coefficient and how these are the addition of shutdown and startup cost. Similar way, and we have to write the shutdown and startup cost equation, equality constant and inequality constant, startup minimum up and down constant, maximum and minimum in similar way. We have to write similar way in other slide also. Okay, so we have to model the unit commitment. Okay, we have to model that, and we have to minimize the MINLP. Why I'm using MINLP? Because these are the mixed integer nonlinear programming. Mixed integer because we are using the unit commitment. That is the binary variable. That's why we are using the MIP or NLP. NLP why? Because they are non-linear. That's why we are using MINLP. MIP plus NLP, that is MINLP. So we have to minimize FT, that is objective function, using MINLP. And we have to display the P output and unit commitment status. So let us see the result, how we are getting. These are the unit commitment result. Means all 1, 3 are all the unit are committed. Means these are the cheapest unit, and 6 to 7, 90, 24 hour. In second unit, the unit will be committed. These are the costly unit because they are committed only 7 to 24 hours. 6 to 24 hours. So this operating cost will be in this. If you go for forecasted wind, if you add wind power, then the cost will be reduces and commitment will be also reduces. Obviously, if you add wind power without wind, the cost will be this. If you add wind power, then cost will be this. Cost will be reduces and commitment also reduces. So that's why we are using at the mode wind power. If you add energy storage also, then cost will be again reduced with the case number 2. So these are the dispatch, because if you go for the unit commitment, it's a binary variable. Then we also go means power also we have to also get the power, that is power output of generator I, means 1, 2, and 3. 3 generators are there. So these are the dispatch of without wind units or with forecasted wind power. So these are the equations which can be used in the most probable scenario. Okay. So now we already studied about what are the economic dispatch and what are the basically which can be used in the power system that area. Okay. So these are all about things which can be used in our day-to-day life, and most of the researchers are doing right now also economic distress problem. So, okay, so I will conclude in this. Okay, shall I conclude? Hello. Because most of the problem are there is will be are largely problem are there. Hello, is it audible to you?
Yes, yes. Thank you. Thank you very much.
I will see a slide, publication slide. My published article is IIT GTT. My first article is the SCI impact factor 3.6 and 765. Journal of Engineering is also the international journal is I have published. In third is International Journal of Electrical Engineering System. Two publications are there. In the earlier month, I have published International Journal of EPES, Electrical Energy System, is the SCI publication. And I have paper also with Scopus also. And national conference as the MPSC 2020 in NIT Trichy are there. I have published NIC, NMPSC, and 3 international conferences are also there. So these are my publication of my work, and these are the key references of my work. Okay, so thank you for joining us and giving support for the programming. So should I conclude this?
Thank you, sir. Thank you, sir, for such an enriching session. The content was quite knowledgeable. I hope many of us has got new ideas for doing research work. So if you allow, we would like to proceed towards the questionnaire session. We are having few questions popping out in the chat box. So if you allow, we would proceed for the questionnaire.
Okay.
Shall we proceed, sir?
Yeah.
Okay, thank you, sir. The first question is from Shovik Ganguly. He's asking, any customization of the program possible in GAMS?
It is possible if you go for the license solver now. Means when we are install the GAMS now, you have to have the GAMS will be go for the license solver. So it will be possible. Most of the trial version, most of the programming you can solve in trial version. So it is easy to way. If you go for trial version, most of the program you can solve easily. So it is not very important task. So you can easily solve. It is possible. It is very easily possible. Okay. Next question.
Okay. Next is from Shubhajit Adhikari. Sir, is it also help to minimize the cost of generator? I think he's asking,
I have already said about the price-based unit commitment. In price-based unit commitment, there is a Janko profit. It has to be minimized, because if you go for a Janko profit, because they have to minimize the profit and we have to minimize the cost and maximize the profit. It will be happen. Genco is the part of a generation company. Though the electricity marketing we are all the system are the monopoly. Genco having on monopoly, distribution having on monopoly, and transmission is also monopoly. So they are the delivery power system. So Genco you have to minimize in GAMS solver. You can easily hold all those problems. Next.
Okay. Next question is again from Shobik Ganguly. Instead of standard solvers, can we use our method in GAMS?
Yeah, you can solve this problem. If you go having large number of constraints, as we already say about that is the mathematical optimization problem. If you go for a large number of large number of problem you have, and large number of constraint you have, you can easily solve by using GAMS. Okay. So it is easiest way to solve this GAMS problem. Okay.
Dear participants, do you have any more questions? Please write down in the chat box. Any more questions? I think at present there are no more questions. Thank you, sir, for such a session. Now, as we have come to the end of today's webinar, I would like to request our Dean, sir, Professor Dr. Ashok Shah, to give the vote of thanks. Over to sir. The virtual dais is yours.
Am I audible, Orindita ma'am?
Yes, sir, you're audible.
Uh, it is my great pleasure on behalf of Regent Education and Research Foundation group of institutions to convey my sincere thanks from bottom of my heart to Dr. Pranda Prashant Gupta, Assistant Professor of Rajaram Babu Institute of Technology, for delivering such a good and knowledge enriching topic of power system optimization in GAMS. Sir, thank you very
Thank you,
much
sir.
for providing us just your precious time from your busy schedule. In future, we would like to have your kind presence in our physical campus, in our Barakpur
Okay.
campus. We would like to have your kind presence there in future.
Okay.
I would also like to thank the HOD of Electrical Department, Professor Vidyut Kumar Ghosh, and Dr. Orindita Saha for coordinating uh, such a this program so that it has grand success today. I would also like to thank all faculty members and technical assistants of the Department of Electrical Engineering, and I would also like to thank all other faculty members of our college and technical assistants of my college, other college, and other universities also for their patience hearing. And I would also like to thank my dear students, and hopefully I'm confident that you have enriched your knowledge by this webinar, and you have been motivated by this research work, and hopefully you will pursue such kind of work in future. So thank you everybody. Thank you very much. Thank you, sir, once
Thank you,
again.
sir.
Over
Thank
to
you,
you,
sir.
or in
Thank you, sir. Now, I would like to request our HOD, sir, Professor Vidyut Kumar Ghosh, to speak few words.
Hello.
Yes, sir, you're audible.
Okay, thank you. Good afternoon, sir. We are highly obliged that you have accepted our invitations and deliver in front of deliver lecture in front of us. So we want to represent a token gift to you as a symbol of gratitude. Please accept it, sir.
Thank you,
Minmay,
sir.
please
Thank you.
share. Please, Minmay, share this. Okay.
Okay.
This
Thank you,
is the
sir.
memento. Okay, this memento will be officially sent by our principal, madam.
Okay,
Okay.
sir. Thank you. Thank you, sir. Thank you,
Thank
sir.
you, sir.
Thank you,
Okay.
sir. Thank you so much.
Thank,
Thank you, all of you. Thank you.
thank you.
Thank you so much.
Thank you very much.
Minmay, please share the link. Hello.
Yes, sir.
feedback
Minmay,
you share. Please share.
feedback link. Please share the feedback link. Okay.
Yes, yes. Hello, feedback is also share. Feed,
Feedback link is provided in the chat box. All the participants are requested to fill it within 1:30 p.m. today. Thank you.